Good day, everybody. We are now on the week 2 of this online training program. The focus is still within the ambit of the basic knowledge on well intervention services as it pertains to the oil and gas industry. So today we will be talking about Slickline tools and applications. Before we start any kind of operations in the oil well intervention services, we've always been very conscious on safety, irrespective of where you are. Please sit back and listen very, very attentively. Your undivided attention is really needed here. Wherever place you listening to this training, try to identify your exit. Should there be anything, identify your restroom. Should there be any emergency, you are not expected to run. Walk briskly after being notified to an assigned mustering point. If you don't have mustering points where you are, try to create one before you will commence on this topic for today, week 2, Slickline tools and applications. 1, I would want us to concentrate on the learning objectives for this week 2 program. By the end of this lecture, you should be able to identify different types of Slickline tools, which falls under the pulling, the running, the shifting tools. You should be able to describe the applications in downhole operations, like setting plugs, retrieving devices, and shifting sleeves. And you also should be able to explain how a tool string is assembled and how redress procedures are carried out. You still would be expected to demonstrate practical skills in identifying tools, maintaining them, and redressing them. These objectives are measurable. What do I mean by they're measurable? It means that you will be tested through both classroom and hands-on sessions. Now, let us do a recap of the previous week training. Before we move forward, let's recap week 1. We studied the fundamentals of Slickline operations. We learned why well intervention is necessary for sustaining production in oil and gas wells. We also reviewed the different categories of well intervention. That foundation is now what prepares you to focus on the actual tools used in Slickline operations. Introduction to Slickline tools. Slickline tools are specialized equipment designed for very specific purposes. They fall into functional groups. Some tools set equipment, others retrieve equipment, some shift sleeves to open or close flow paths, others help in diagnosis of downhole conditions. Choosing the right tool determines whether the operation succeeds or fails. A wrong tool is tantamount to waste rig time misruns of unavoidable or avoidable fishing jobs. The correct tool, what would that lead to? Efficient, safe, and cost-effective operation. So we should be very, very careful about this. So we're going to sort of talk about the pulling tools, an overview of the pulling tools. Pulling tools are used to correct or to retrieve devices, not to correct. They are to retrieve devices from the well. Examples include GS pulling tool, GRO pulling tool, and HD pulling tools. They work by latching onto the fishing neck of the device in whole, holding firmly to allow retriever to surface. If the tool is the wrong size or not properly dressed, it may fail to latch, leading to misruns or stock tools. Pulling tools applications. Pulling tools are widely used in retrieving wireline set plugs, pulling lock mandrels from side pocket mandrels, removing check valves or other flow control devices, fishing operations when equipment is stuck downhole. That's where we deploy pulling tools. This makes pulling tools some of the most essential Slickline tools. What about the running tools? The running tools do the opposite of pulling tools. They are used to set equipment downhole. Common designs are the Arrow tool, X tool, Otis running tools. They operate by attaching to the equipment at surface, running it to the correct depth of interest, releasing it securely into place. That's right inside the well. What about the running tools? We've talked about the pulling tool. We've talked about the running tools. Overview. Now, this application. Running tools are applied in setting plugs to isolate production zones. Running lock mandrels into side pocket mandrels. Deploying check valves in gas lift systems. Installing other flow control equipment. Accuracy is key here. The tool must release the equipment at the correct depth. Take note of that. What about the shifting tools? Let's have a good view about the shifting tools. Shifting tools are designed to manipulate sliding sleeves in the tubing. They are fitted with keys and dogs that engage sleeves profiles. Examples are the B shifting tools, the JDC shifting tool. They allow Slickline operators to open sleeves, close sleeves, reposition sleeves. That's basically what the application of these tools are. Then we come to shifting tools applications. Shifting tools are used to open sleeves for stimulation or chemical injection. Close sleeves to isolate certain zones, especially in multi-zone wells. Redirect or control fluid flow for production optimization. This makes shifting tools critical for reservoir and production management. Tool string assembly. I remember in one of my sessions, in one of the companies, I worked for a very brief period, Welbeck precisely. I showed the trainees the sample of a two-string assembly. What is this two-string assembly? The two-string is a sequence of connected tools. The correct order is as follows. 1. The rope socket comes first in the two-string assembly. The rope socket attaches Slickline to the two-string. Then we have the stem after the rope socket. The stem could be a weighted bar or just ordinary stem, and this provides weight to carry tools down. Next is the jar. The jar delivers impact to set or release tools. Then the service tool comes at the end of the two-string. The service tool could be pulling, running, shifting, LIB. Does the job of what make the Slickline operations to be carried out. The service tool are very varied forms, and that is always the end of the two-string. If assembled wrongly, tools may not function correctly. We must guide against that. Now, what is the redressing procedures? Redress means inspecting and restoring a tool before its next use. Steps include disassemble the tool, clean thoroughly, inspect for wear, tear, and damage, replace worn-out parts such as dogs, springs, sharpins, seals, reassemble and test function correctly. Redress is compulsory. It ensures tools don't fail downhole. The hands-on tool identification. Practical skill. Learn to recognize tools on site. Check for types, pulling, running, shifting, components like dogs, keys, latches, shear pins. I've seen in some instances where instead of using a brass, some inexperienced operators went to use copper and they had problem. So, tool identification is very key here. Correct dimensions against standards. This prevents wrong tool usage and misruns. Maintenance practices. Good tool maintenance includes cleaning tools after every run, applying anti-rust oil, not all oils that you use in servicing your tools, anti-rust preferably, immediate replacement of worn-out parts, keeping a tool history log for traceability. Well-maintained tools is tantamount to higher reliability and lower downtime. So the option is yours. For me, I've always been very particular about effective maintenance practice. Whether you are a graduate trainee or you are an enthusiast or somebody, irrespective of the fact that the course you read and you have that zeal to learn these basic oil well intervention services, you should be able to apply yourself to assemble two-string under supervision. Practice redressing, pulling, and running tools. Identify tools by their design and purpose. Record tool condition and maintenance data. This is your transition from theory to practice. So you give it more than the usual attention it deserves. Now we're coming to the practical exposure. Don't be worried that, you are not having the tools in your hand, because as we progress, as long as you're a participant of this training program, at the end of week 12, you should be able to have a very sound foundation. Then when you see the tools, you immediately know this is what they're talking about. You participate in two-string assembly exercise, redress drills for pulling and running tools, shifting tool identification practice, tool maintenance workshops, that is cleaning, inspection, and storage. This is hands-on learning, essential for competence. What are the expected competence? By the end of this week 2, this particular week 2 we are dwelling on, you should be able to identify Slickline tools and their functions, assemble a basic tool string correctly, redress pulling, running, and shifting tools, demonstrate safe tool handling and maintenance. This competence is the benchmark for moving to advanced practices after intermediate. Now, we'll move on to a case study. The case study is this. It has to do with a beam shifting tool failure in a particular Slickline operation. But I will leave this after we've gotten to the end of this week 2 training. So I will elaborate on this case study. It will drive home the importance of maintenance safety in our Slickline operations. But just have in the back of your mind, we'll be talking about the beam shifting tool failure in a particular Slickline operation. So in summary, therefore, for this week 2 training is this. Pulling, running, and shifting tools are the core Slickline tools. What did I say? Pulling, running, and shifting tools are the core Slickline tools. The applications include setting, retrieving, and shifting equipment in hole. Correct two-string assembly and redress are essential for reliable operations. Hands-on practice in tool identification and maintenance ensures competence and safety. Now, this summarizes the week 2 training. Like I said, we'll move on straight to the case study. As I begin this session, now the case study, I want to remind everyone that a beam shifting tool is a key instrument used in Slickline operations to open or close sliding sleeves in tubing. When such a tool fails, the impact can be costly, both in time and money. So this case study is one I want you to learn from carefully because it reflects real challenges faced in the field, many Slickline fields. The key message from me, therefore, to you listening to this training is that every failure on location offers us a lesson. Our goal as professionals is to learn, adapt, and ensure we don't repeat the same mistakes. The job overview for this case study is this. The objective of this particular job was to open a sleeve at 7,842 feet for gas lift communication. The well had 3.5-inch tubing with multiple sleeves. The tool string consisted of a rope, socket, stem, jar, knuckle joint, a bead shifting tool, and a gauge cutter. As I always emphasize, every crew member must understand the function of each tool in the string. For example, the jar provides impact, while the knuckle joint gives flexibility in deviated wells or in deviated conditions in the well. I have a question for you. Why is it critical to confirm the sleeve type before selecting a shifting tool? Here is how the operations went, but have that question in the back of your mind. And what is that question for emphasis? Why is it critical to confirm the sleeve type before selecting a shifting tool? We started with a clean gauge run, then ran the bead shifting tool to 7,842 feet. After several jarring attempts, there was still no shift. Suddenly, the surface tension dropped and the tool string parted below the jar. Could you imagine that? Fishing became necessary to recover it, increasing your wear cost. This is a classic example of how rushing and forcing a result can lead to tool loss. The lesson one here is this: when engagement is uncertain, stop and verify. Never force what you can't confirm. What was the findings? Upon recovery, the bead shifting tool's key were bent. The shear pin had failed prematurely, and the fishing neck was deformed. A post-job review revealed that a C-type sleeve had been installed instead of the B-type shifting tool. So at this point, a B-type shifting tool was mistakenly used. Also, the tool had not been properly redressed before the job. Poor maintenance culture. So my emphasis here is that tool identification and maintenance must never be assumed by any operator. They must be verified. If possible, have a second eye to verify it, not just you alone. And what is the root cause of all this drama that is costing the client money? Several small errors combine to create this failure. 1. Wrong tool selection, excessive jarring before confirming engagement, poor tool maintenance, no pre-job verification of sleeve type. From my years of experience, I, Benjamin Evuarafo, a consultant, I can tell you that most field failures result from human oversight and lack of verification. So take this from me. Always cross-check completion files and confirm sleeve profiles before mobilization. Consequences. This single oversight resulted in 14 hours of non-productive time, otherwise known as MPT, extra costs for fishing and potential sleeve damage. Crew fatigue and pressure to complete the job worsened the situation. I want you to understand the chain reaction that one wrong decision can trigger. Always remember, the true cost of error is more than money. It includes time, safety, and reputation as a company. Ask yourself, what's the real cost of skipping verification? Haven't listened to this, my lecture. The lessons learned here, therefore, is this. Always verify sleeve profiles, redress and function test tools before deployment. Avoid excessive jarring without confirmed engagement. Keep accurate maintenance and tool usage records. Maintain discipline even when under pressure. In my field supervision experience, discipline is what separates a successful operations from a failed one. Share any similar field challenges you faced and how you handle them within your crew. And if you've not been privileged to be in a crew, always have an opportunity to listen to when people share their views or their experiences in the field that involves failures during well intervention operations. Now, the mitigation strategies, which I would highly recommend for you. To prevent reoccurrence, I always recommend these measures to young operators, even the supervisors. Develop and use a pre-job checklist covering tool verification, slave confirmation, and surface function tests. Implement a stop and verify protocol when tool behavior is suspicious. Train crews regularly on mechanical shifting principles and sleeve identification. Keep digital logs of tool redress and maintenance history. If you wouldn't mind, I would want you to draft a pre-job verification checklist in your own words before our next session on week 3. So to wrap up this week 2 training, I want you to understand that most slickline failures are preventable with the right mindset and preparation. Proper planning, verification, and teamwork are the key pillars of success in any oil well intervention operation. My final word for you is this: patience, verification, and discipline always win in slickline operations. So these principles have guided me for years, and that's why I'm talking to you as an expert. Let them guide you too, please. And may I call this at the end of week 2? By week 3, we'll do more complex slickline operations. Thank you very much for your rapt attention. See you next.